Hey guys, let's get started. So eventually, let's take a look on this given problem. We are given we are given couple of nodes, right? And the startup has been prototyping sensor firmware on these gap networks. So there are two servers, node 1 and node 2, right? They are both sitting in the private subnet with this given IP range. And they cannot reach outside the world, which is a blocker for any package, install, software updates, and container images, right? You might ask me that what's the reason why these nodes are not connected to the internet, but there might be own internal reasons, for example, to ensure the security, reliabilities, and further things, right? Now let's go ahead and understand what's happening over here, right? So what they have said is that they have installed a third host, which is Node 3, and this particular host has a logical interface, like it has this interface which is connected to the private network over here, and it has another interface which is connected to the public network over here, right? So eventually, the idea of this given question is that we need to convert the node 3 into a NAT gateway and wire up the routing so that the private host can reach the internet while at the same time remaining invisible from the outside. Okay. So these are the private networks and these are the home gateway, right? So at one side, the public network is actually 10.0.0.10 and this is connected via the Eth1. And on other side, on the Eth0, we have the another private range, right? So how do you guys actually connect it? So first try to understand it, right? Whenever the packet starts from node 1 and it tries to, let's say that you're trying to access www.google.com, right? So let's say that you're trying to access www.google.com and let's say that the particular node realizes the IP is actually 1.1 and it falls it outside the given private network over here, and basically it cannot find it over this given IP range, right? So it says that I will forward this given packet to the NAT and let the NAT decide that how it should handle it accordingly, right? So eventually every packet has to leave and eventually it has to reach the node 3, right? Every packet in the sense the packet originating from node 1 and node 2. So the first thing we can eventually do is that we can update the NAT of the node 1 and node 2 such that any packet, right, if we want to access the internet, can eventually reach node 3. So for that, what we can do is that we can just add a default, we can just update a NAT 192.168 dot 178.100, and we can apply the same thing to the node 2 as well over here, right? So eventually you can see that we have completed the two challenges over here, which is updating the IP. Now the final thing which I want to explain is that so first of all, I think so with the very first thing which is clear is that it is some like a private lab network, right? H0 refers to the private lab network of this one, and other is configured with a public network, right? So the problem over here is that the when the packet actually arrives at zero, node 3 will not get an idea that what it should do with the particular packet, right? It will not get an hallucination that, hey, I need to take this particular packet from H0 and then I need to forward it, right? So whenever such thing arises, just you need to update the you need to add the IP forward rule itself over here, right? So we can do this task with the systl commands, we can basically add it IPv4 IP forward, right? And okay, I think so I added in the wrong one, right? So okay, never mind. I added in the wrong node. So you always need to take care of if you're adding in the correct node or not, right? So let's go ahead and copy paste this. So this is still has to be added in the particular node 3, right? So once we have added it correctly, now we can say that all the packet which is arriving at the node 3 can eventually be used for the forwarding thing, right? So that is the basic idea of the forward itself, right? So you can read over here that Linux system do not forward packets between the interfaces of the same machine. The gate we need to specify it explicitly over here, right? So once we have specified it explicitly, we can then move ahead and see how we can see. So eventually, if you look at the packet which is originating from the node 1, eventually they will have a source which refers to their given IP address, like 192.168.100, like let's say that's something like this. It's 178, sorry. And eventually they will have this particular source, right? But you know that this source is wrong, because eventually any packet which is leaving eth1, right, it has to be something which the public network can reach back. Because let's say that you send okay, I'll explain you with the basic thing. Let's say that this is your node 1, right, and let's say that this is your node 2, and let's say that this is your, let's use a different color, right? So let's say that this is node, okay, we use a pen. This is node 1, this is node 2, and this is node 3, right? Okay, we have added too much node. Let's just get back on nodes, and let's say that this is node 3, and this is 3, and this is your router, basically. Let's say that. Now try to understand that whenever a packet reaches this one, this will come with the particular 192 to 168, right? And if you just forward this packet to the router, right, and the router replies back, do you think the router will actually be able to reply back? No, because this is a part of the private network itself, right? 192 is a private network. Router will not be able to identify that, hey, who's this packet belongs to, right? So even though you're forwarding the packet has to be rewritten. The packet has to be rewritten in the format that it has to, we have to update the given packet with some public network, right? So that the router can say that, okay, there was a request of accessing some particular destination from this particular network, public network, and I'm going to handle that request. And once the reply comes from that particular server, I'm going to reply it back to the node 3 itself over here. And then node 3 can internally take care of forwarding the packet to the particular node. So these are some advanced concept in Linux, and eventually they are called masquerade, right? So as you have specified over here, that forwarding packet is fine. Like you can forward the packet from private to public, right? But it does not solve the address problem, because the packet which leaves, will have this address, right? So the router will drop any reply which is part of the local private, like private network itself. So that's why we need to update the source address of the packet, right? So that is one thing. So that's why we're going to use a network address. We need to update our network address translation table, so that eventually the source IP address, before they leave the private network, they can come back, right? The reply can eventually come back. So eventually, if you look at it, so this was the path or the port at which the packet was leaving from node 0, right? This was the IP address of the node 1 machine, and this was the particular port. And eventually, you can see over here that this got eventually rewritten with some different, right? And this, okay, this is actually the request, right? This is actually, sorry, the destination request, right? So eventually, the node 3 gateway rewrites this source, and it says that, okay, this gets updated with 10.0.0.0, which is the part of the public network over here, right? Eventually it gets updated, and I'm going to forward this request, right? I'm going to forward this request, and once the reply comes back, I'm going to translate it back, right? As simple as that. So for this, we have some special commands where we go and update our IP tables. So since we are updating our IP tables, you can use the NAT logic over here. So we need to, this is the command for it. And the only thing which you need to take care is that we need to append the eth1 over here. So the post routing says that after applying, the post routing applies. So the source IP get rewritten as the packet leaves eth1, right? And the masquerade makes all the traffic appear as if we are going to attach a masquerade command itself over here. So masquerade, the masquerade makes it look like the all the traffic from a private network appear as it was coming from an external IP, right? So let's see that if we enable this thing, right, we are so far good. And whenever we do any kind of ping, let's say that ping 1.1.1, you can see that the request is actually going through, right? And we can perform the same operation to the node 2 itself. So now both the nodes are actually connected to the internet, and this is the way to do it, right? So for the people who want to understand more, you can use the man pages thing, right? Man pages thing to eventually read more about it. Otherwise, you will always have this pretty fun section. So let's see the man pages for this thing, right? So eventually, there are a lot of things over here, right? So if you want to read that what does O means over here, it's just specify that the name of an interface by which the packet is going to be sent. So eventually I had used O.eth1, So that is for that given thing. And I had also used T over here, right? So I needed to make you understand why I'm also using a T over here. So somewhere over here you will be able to find it. MGHIJK. I'm so bad at alphabets. Or not. So yeah, okay, we have a table over here. So this specifies the packet matching table, which the command should operate on. So if the kernel is like basically you can supply there are different type of there are five independent tables over here, which I'm not going to go through this over here. So if you have a T option which is passed over here, it's just specifies the translation for this given thing, right? And with T we have specified the we have passed the parameter NAT, right? So what it eventually does is that the table is consulted when the packet that creates a new connection is encountered, right? So basically it contains four things over here: pre-routing, input, output, and post-routing. So what we needed to do was that we would be alternating or altering the packet itself as they're about to go out, right? So that's why we use the hash t command with NAT. So applying the post routing. So as they're about to go out, they can be altered, right? And for any other things for altering the packet designed for the local sockets, you can eventually use this. For the pre-routing, for altering the packet as they come in, right? You can use the pre-routing over here. So these are some concepts which you can eventually go and figure out while you're trying to play with this commands over here. And finally, we are going to understand about the masquerade commands over here. The masquerade commands is somewhere over hash J. So this specifies the target rule, right? What to do if the packet matches it, right? So this is just a packet matching thing which has been specified over here. So the target can be user-defined chain, like you can have your own matching pattern over here. If the option is omitted in the rule and the matching will have no effect on the packet, blah blah blah. So just packet this specify the target of the rule, that is what to do if the packet matches it, right? So just packet matching thing, not to worry much about it, right? So core things we have I have explained to you guys, right? So as part of T command, you can also explore the filter command. Like it's just something which is outside, and I don't know if you were interested on it. Like so even I'm actually studying with you guys, right? This is also something new for me. So we have a mangle command, which is specialized packet alteration until it had two built-in pre-routing and post-routing. Since kernel three built-ins are input. Okay, this mangle is not something. The mainly used for configuring exemption for connection tracking in combination with input tracking. This is used for mandatory networking rules such as those enabled by SecMark and COSMark. Mandatory is implemented by the Linux curry modules, SecLinux, and is called after the filter table, allowing any discretionary access control rules in the filter table to take. Wow. So yeah, it's actually pretty fun when you play with man pages because this actually gives you so much knowledge over here, right? And the IP table is something similar to the IP chain. The main difference is this, that, and all, right? Rusty Russell originally wrote IP tables in earlier. So yeah, it's fun. That's all, guys. So I hope you enjoyed the video. If you have further questions, you can do let me down know in the comment. Right? We will be solving more challenges as we come ahead.